Hey everyone, in this video let us discuss everything about ligands. So there are two types of classification, okay, and we know how important the ligand is. Ligand is an atom or a group or an ion which can directly link to a central metal atom through a dative bond or coordinate bond. And we know that ligands will act as Lewis bases, right? So they always donate a pair of electrons to the central metal atom. So such ligands are broadly classified based on two factors. Okay, classification of ligands based on denticity and classification of ligands based on charge. So this is how you are going to study two ways of classifying ligands. First, let us understand about classification based on denticity. Okay, so first and foremost, you need to understand what is the meaning of this word called denticity. It is very simple, guys. Denticity means number of donor atoms present in a ligand. Okay, or we can also say that number of coordinate bonds, which are nothing but dative bonds, isn't it? So number of coordinate bonds formed per ligand, per each ligand is called as denticity. Suppose from one ligand, if you can form two coordinate bonds, you know, each donor atom will give one coordinate bond, right? So denticity means having number of donor atoms or having number of coordinate bonds formed from each ligand. Okay, from each ligand if you can form two coordinate bonds, then we say denticity is 2. From each ligand if you can form 4 coordinate bonds to form, you should have 4 donor atoms, right? So that is what we mean by denticity. If you have 5 donor atoms, 5 coordinate bonds can be formed, then denticity is 5, we say. Okay, so denticity is nothing but having it is the number of donor atoms present per ligand, or we can say the number of coordinate bonds formed per ligand is called as denticity. Okay, so now based on denticity, okay, we can have 3 or 4 types of ligands, guys. So the first one is monodentate ligands. Monodentate ligands. Second one, bidentate ligands. Bidentate. Okay, or we can also call it as didentate ligands. And thirdly, we have polydentate ligands. Okay, so here monodentate you can say, or unidentate ligands also we can say. As the names tell you, monodentate ligands are the ligands which have only one donor atom. So they are the ligands which have only one donor atom. One donor atom in the sense they can form only one coordinate bond with central atom. Okay, they form only one coordinate bond with central metal atom. CMA in the sense central metal atom. Okay, so such ligands are called monodentate ligands. Now I'll give you the list of monodentate ligands. So here I'll give you the list of monodentate ligands. So very simple. So it can be a halide ion. Okay, so you can have Cl minus, Br minus, you know, I minus. All these are monodentate ligands. Okay, or you can have OH minus. Okay, so here the donor atom is X. Here the donor atom is actually O. O is a donor atom. Okay, fine. and you have NH3. This is a monodentate ligand where donor atom is N. There is a lone pair on nitrogen, guys. So this is what a pair of electrons donated by ammonia molecule. Or you have cyano ligand, Cn minus. Okay, so or you have CO, carbonyl ligand, CO. Okay, I'll again once again give their names separately when I discuss about their charge. Okay, so now I'm just giving the different examples for monodentate ligands. Okay, or you also have NO2 ligand or VONO. So there is a difference, guys. NO2 ligand is different, ONO is different. I mean to say, this can be called as nitro ligand. This can be called as nitrito ligand. Okay, so both of them are monodentate ligand, but the donor atoms are different here. So in case of nitro ligand, the donor atom is N, guys. Okay, in case of nitrito ligand, the donor atom is O. Okay, so such ligands are actually called as ambidentate ligand. This is also very, very important. Ambidentate ligands. So for many board examinations, they will ask you the definitions of ambidentate ligand. Ambidentate ligands are monodentate ligands. They are monodentate ligands. Okay, with two donor atoms. Two donor atoms. And one coordinate bond is formed at a time. Okay, so here I'll write that point. One coordinate bond is formed at a time. Okay, so this can be a definition of ambidentate ligand. Okay, see here, for example, you have NO double bond. Okay, so here if a linkage is from O and central metal atom, then it can be called as nitrito O. Linkage is through oxygen and central metal atom. Okay, fine. Or if the linkage is from N and central metal atom, okay, O minus double bond O. See here, the same nitro ligand, linkage can be from oxygen and central metal atom, or linkage can be formed from nitrogen. So here oxygen can behave as a donor atom, nitrogen also can behave as a donor atom, but only one bond at a time. From both at the same time bond formation you don't observe. Okay, only one bond at the same time, guys. Either bond can be formed from oxygen or the bond can be formed from nitrogen. Okay, so here if a bond is through nitrogen and central metal atom, then it can be named as nitrito N, or you can just call this as nitro ligand. Okay, so this is one best example for ambidentate ligand. Another example is there for ambidentate ligand, SCN and NCS. Okay, SCN bond can be from sulfur and central metal atom, or bond can be from nitrogen and central metal atom. Okay, so whenever the bond is from sulfur and central metal atom, then it can be called as thiocyanato. This ligand is called as thiocyanato, and this ligand can be named as isothiocyanato. Okay, so don't worry, I'll give their charge, name and everything separately when I discuss about their charge, classification of ligands based on charge. As of now, just understand the concept, what actually we mean by ambidentate ligand. Okay, so remember, these two are the best examples of ambidentate ligand. One is nitro, the other one is thiocyanato. Okay, so both of them are really very important. And there is one more example for ambidentate ligand actually, that is CN. So here also cyano ligand, this can be called as cyano ligand. Bond can be formed from C and central metal atom, or NC, bond can be formed from N and central metal atom. Okay, so this can also be an example for ambidentate ligand. Okay, so 3 examples I gave for ambidentate ligand. One is nitro, the other one is SCN, thiocyanato variety, the third one is cyano variety. Okay, so they have 2 donor atoms, but single coordinate bond is formed at the time. Okay, so that's why they come under monodentate ligands. So all these are different examples of monodentate ligands. Okay, so they have 1 donor atom at a time. They form only 1 coordinate bond with central atom at a time. Okay, so they are all monodentate ligands. Now let us talk about bidentate ligand. Okay, so now let's understand what is bidentate ligand. So as the name suggests, so 2 donor atoms, you will observe 2 donor atoms per ligand. Okay, each ligand will have 2 donor atoms. I mean, from each ligand you can able to form 2 coordinate bonds with the central atom at a time. Okay, so the best example here is ethylene diamine. We can shortly call it as ethylene diamine, we say. Okay, so it can also be called as IUPAC name of this is ethane 1,2 diamine. This is the IUPAC name. It can be abbreviated as EN. We can write this in shortcut EN, that means ethylene diamine, ethane 1,2 diamine. Okay, so look at this structure, ethane, that means CH2 CH2 NH2 NH2. So this is what we mean by ethane 1,2 diamine or ethylene diamine. So here there are 2 nitrogens, both of them have got lone pair of electrons. So this nitrogen can be a donor atom and this nitrogen also can be a donor atom. So from each ligand, this whole thing is 1 ligand, from each ligand 2 coordinate bonds can be formed with the central atom. Dative bonds are always represented with arrow mark, right, from donor to acceptor. So such ligands are called bidentate ligand. And another beautiful example is there, that is oxalato ligand. So this is example number 1 and I am giving you example number 2, oxalato ligand, guys. So this is also very simple. See, oxalic acid we all know, COOH, bond COOH is called oxalic acid. Oxalic acid. Remove these 2 hydrogens, what do you get? COO minus, COO minus. See here O minus, this is one donor atom, this O minus is another donor atom. So from each ligand 2 coordinate bonds can be formed with central atom. So oxalato ligand in short can be written as OX. Okay, so OX means oxalato ligand. Okay, it can have a formula, see 2 carbons, C2, 4 oxygens, right, O4 and 2 minus charges, minus 2. So this is the formula of oxalato ligand, C2O4 minus 2. Okay, got to know? So this is another example. Now let me give you third example for bidentate ligand. So whatever examples mentioned in NCERT textbook, all of them are very important to remember. Out of NCERT is not necessary. So I am just mentioning the examples which are there under NCERT. So ethylene diamine is one example mentioned, oxalato ligand is another example, and third example, try to remember glycinato ligand. Glycinato. Okay, so we know the chemical formula of glycine, right? CH2 COOH NH2. This is what we mean by glycinato, right? So if I remove this H here, what do I get? CH2, NH2 and COO minus. See here there is a lone pair on nitrogen, so that is one donor atom, and O minus is a donor atom. So from each ligand, 2 coordinate bonds are formed with central atom. Okay, so this can be normally abbreviated as GLY, glycinato-ligand we say. Okay, so 3 examples we studied for bidentate ligand. One is ethylene diamine, this is a very common example. Second one is oxalato-ligand. Okay, third one is glycinato-ligand. So each ligand is forming 2 coordinate bonds with central atom, right? So all of them are examples of bidentate. Now let us discuss about the polydentate ligand. So let me erase all of them and let's go for polydentate ligands here. So this is also very simple. Polydentate ligands will have more than 2 donor atoms. More than 2 donor atoms. I mean more than 2 coordinate bonds can be formed from each ligand. Such ligands are called as polydentate ligand. Okay, so look at here. We have something called diene. Okay, so example 1 I am giving you something called diene. We have diene in the sense diethylene triamine. Okay, see, you can write like this: NHCH2 ethylene groups, 2 groups are there, CH2 and corner 1 amine group, NH2. So if you can make out the donor atoms, see here 1 nitrogen, 1 donor atom, here central nitrogen, another donor atom, this last nitrogen, another. So from each ligand itself you have 3 donor atoms, so 3 coordinate bonds can be formed, okay, with 1 ligand. So this is actually an example of tridentate ligand. Okay, tridentate in the sense 3 donor atoms you will find in a single ligand. I mean 3 coordinate bonds that can be formed from a single ligand is called as tridentate ligand. So this one can be an example of polydentate ligand. Polydentate ligands can be tridentate, tetradentate, hexadentate, pentadentate and so on. Okay, so this diene is there, no, this is an example of tridentate ligand. Likewise, look at the second example I am giving you, triene. So you have something called triene. Triene in the sense triethylene tetraamine. Okay, so if you can try how to draw its structure, look at here, N, okay, H, CH2, again NH, CH2, this side I will put one more, triethylene, so 3 ethylene groups, so corner 1 NH2, this corner 1 NH2, okay, see here 1, 2, 3 ethylene groups and tetraamine, 1, 2, 3, 4 amine groups. So all 4 nitrogens have lone pair, right? So definitely all of them can behave as a donor atom. So from each ligand 4 coordinate bonds can be formed with central atom. So they can be called as tetradentate ligands. So they are tetradentate ligands, I can say. Okay. See guys, I gave you a list of ligands under negative, neutral and positive. See, like I said, negative ligands are the ligands which carry negative charge. Here, which ligand has carried how much charge is important. The charge of a ligand is important to calculate oxidation state of central atom, which we will discuss in the next video. Okay, and also name of a ligand is important. Name of a ligand is important to write the IUPAC name of a complex. That also we'll discuss in the future videos. So whatever the list of ligands I gave you, their charge and their names are compulsory to remember. At least these ligands you need to know their charge and name. So now let us discuss. First, negative ligands. Negative ligands name will always end with the letter O. Okay, see, F minus can be called as fluoro, or it can also be called as fluorido. Fluorido is fine, fluoro is fine. Okay, and Cl minus can be called as chlorido. Chloro is fine, chlorido is also fine. Br minus is called as bromido, and all these halogen ions, what is the charge? -1, right? See, 1 minus I have put in the sense -1. -2, here the charge of sulfate ligand is -2. Charge is important, name is important, both are important. Without this you can't write the names of complexes, you can't calculate oxidation state. Okay, fine. And NO2 minus, this can also be called as nitro ligand, or it can also be called as nitrito N. Okay, linkage we will mention. So whenever we write like this, linkage is from N and central metal atom. Donor atom is N, guys. So that's why we write N here in the name. Nitrito N you can write, or just nitro is also fine. ONO minus can be called as nitrito O. Linkage is through oxygen and central atom. So nitrito O, and both of them have got, what is the charge? -1 is the charge they carry on them. Okay, and now this is called as cyano ligand, or cyanido also we can say. And OH minus is hydroxido, and CH3COO minus acetato, and NO3 minus is nitrato. Okay, NO2 minus is different, NO3 minus is different. NO2 minus is nitro or nitrito N, whereas NO3 minus is nitrato. This is ambidentate ligand, but this is not ambidentate ligand. Do remember that. Okay, and now CO3 charge is -2. CO3 is named as carboxylato, and this is oxalato ligand. In the previous case I said, right, which has got -2 as the charge, 2 donor atoms, 2 O minuses you have here, right? Oxalato. And this is sulfato, which carries again -2 charge, and this is thiocyaneto, yes. Okay, linkage is through S and central atom. So ambidentate ligand, this is also ambidentate ligand. Linkage you have to mention, guys. Okay, and this can be called as thiocyaneto N, you can say. The linkage, see, the first written atom is what? The donor atom, guys. Okay, so here the first written atom is N, here the first written atom is O, that way. Okay, so the first written atom is a donor atom in ambidentate ligands. So thiocyaneto S, thiocyaneto N. This can also be called as isothiocyaneto. It has got another name, isothiocyaneto. But most commonly thiocyaneto N is what we use. And this is called as oxido, but this is peroxo we say. Okay, so there's a difference. Single oxygen, single O, oxido. O2 -2 is peroxo. Okay, so all these are commonly observed negative ligands. Okay, whose charge is important to remember and whose name is also important to remember. And coming to the neutral ligands, all neutral ligands have got a charge which is equal to 0. So whenever you find these ligands in a complexes, say if you want to calculate the oxidation state of central atom, you are supposed to consider the charges of ligands. So if you have these ligands, consider the charge as 0. That is the reason they are called neutral ligands. and neutral ligand names are different. You know, NH3 can be written as amine. See here, all negative ligands name, if you observe, you know, the ending was with the letter O, but here no such things, so their common names only can be used, okay, as their names. CO is called as carbonyl ligand, one of the strong ligand we say. H2O is written as aqua, guys, okay. And En we know, we have just now discussed, it's one of the bidentate ligand, ethylene diamine. You can write it as ethylene diamine, or you can write its IUPAC name ethane 1,2 diamine. And this is methanamine. Its name is methanamine, okay, charge is 0. And this is also one of the very important ligand, C6H5 thrice, phenyl group, right? So how many phenyl groups are there? 3. So triphenyl phosphine we say. Triphenyl phosphine, which has got 0 charge. And this is pyridine. In short, it can be abbreviated as PY. So this is pyridine we say. And this is very important ligand, nitrosyl ligand. Okay, so these are very commonly observed neutral ligands. And now coming to positive ligands. So I am giving you only 3 examples of positive ligands. And the positive ligands are very rare, guys. Ligand is something which should give a lone pair of electrons, right? So negative charge, yes, they are rich with electron, they give their electrons. Neutral ligands, since you have some atoms with lone pair here, they donate their electron. But positive itself means they are electron deficient. Then how can they act as ligands is a big question mark, right? So that's the reason positive ligands are very rare, but still we have positive ligands, 3 of them. And this is very important. This is called as nitrosonium or nitroselium also we can say. See here, NO can act as both neutral ligand as well as it can act as positive ligand. Only in one case it can act as a positive ligand, that is in brown ring reagent. Okay, so brown ring reagent is a complex of Fe, H2O, 5 times NO. Okay, so this is that brown ring reagent, brown ring compound. Okay, so you will do a test for nitrate now, where you will observe brown ring formation in a test tube during practicals. Brown ring compound is this. Only in this compound the NO's oxidation state was taken as +1. I mean NO is considered as positive ligand. In rest all the complexes, if NO is there, consider it as a neutral ligand. That means consider its charge as 0. Only in this complex, only in this compound, the NO is taken as +1 oxidation state. Okay, so NO will behave as a positive ligand. In all other complexes, in case if NO is there, except that, okay, you are considering your NO as neutral only, I mean with 0 charge. Okay, so this is one very important point to be remembered. And this positive ligand can be called as hydrazinium. You know what? Positive ligands names will end with IUM. Like negative ligands name end with O, right? So likewise here positive ligands name will always end with IUM. That's why ending you can see nitrosonium, hydrazinium, and this is nitronium. Nitronium ligand is also very rare. And for your level, I mean for 12th level, you know, whenever in a complex you see NO2, always consider NO2 as a negative ligand. Consider the charge as always -1. Don't consider it as positive. Only in case of NO, remember that too, NO in this complex itself it is taken as +1. In rest all other complexes it is taken as neutral only. I mean the charge is 0. Okay, so this is one very important aspect you should not forget. So this, whatever I told you, whatever the list, names, charges I gave, all these are very important to understand how to calculate oxidation state and also to write the names of complexes. So that's all about the classification of ligands. In the next video, I will teach you how to calculate oxidation state of central atom and about coordination number of complexes.